Okay, welcome to pre-calculus, the first lesson, the number system. Let's talk about real numbers and what types of numbers make up the real number system. Okay, the real number system is a number system made up of natural numbers that start at 1 and go in whole amounts to positive infinity. The next number system is the whole number system, which starts at 0 and go in whole amounts, increasing order to positive infinity. The next number system is called the integers, and that is your positive and negative numbers. The next number system is called the rational numbers. Here's where you have your decimals that can be fractions. And the next number system over here are your irrational numbers. These are numbers whose decimals do not repeat and do not end. And all of these numbers make up the real number system. They are subsets of the real number system. Okay, here are the definitions. You can read through them. But what I want to do is highlight what a rational number is. Now, if we take a whole number like 7, we can put that number over 1 and make a fraction out of it and do our fraction math with it. Or we can add a decimal to 7. Put a decimal at the end and make it 7.0, which is a rational number. So all whole numbers can be divided by 1 because any number divided by 1 is itself, or put a 0.0 at the end to make it a decimal. And we can add as many zeros to the right of a decimal we want. So if we had to subtract like 35 ten thousandths, we can do that. We would just add our zeros and do the operation. Let's talk about a new number system, complex numbers. You learned about this in Algebra 2. So in Algebra 2, you learned about complex numbers. What is a complex number? It's a real number like 3i. And what is I? I equals the square root of -1. So 3i is 3 times the square root of -1. Now, what you learned in Algebra 2 is that when we take the square root of a negative number, it's not possible. So then we had to make up a new number called the complex numbers. So if we took the square root of -9, what you're supposed to do is separate it into -1 times 9. We know that the square root of -1 is I, and the square root of 9 is 3. And in algebra, we always write our numbers first. So we write 3i. And that's where we get this number from. This is a new number. Now, also what we need to say is look at these letters next to the number systems. The complex number is indicated by a C. So whenever you see C, this identifies our complex numbers. Real numbers are indicated by the letter R. Rational numbers is indicated by the letter Q for quotient. So a rational number is any decimal that can be turned into a fraction. I don't know why the integers are Z, but the integers are called Z because the irrational numbers are called I, and I don't show irrational numbers on this circle chart. Whole numbers are indicated by W, and the natural numbers are indicated by the letter N. So these letters represent different types of number systems. Okay, here's the definition of an imaginary number and a complex number. An imaginary number is a number without a real part. It's just pure imaginary. And a complex number is a combination, as we can see on this slide. What do we do with this slide? So in Algebra 2, you were introduced to the real number system on the x-axis, where this was called real, and where this was called imaginary. The y-axis is now called the imaginary system. And so this is the way it works. I to the 0 is 1, positive 1. So we are one distance away from the origin, 1 unit. I is equal to the square root of -1, or -1 to the half power. I squared is I times I, which is -1. I cubed is I times I, which is -I. And I'll do that on the next slide to show you how we get from where to where. But this circular thing is important because these repeat. So we can find I to the 8th, I to the 9th just by dividing by 4, because 4 is the repeat point, and then we just count around from 4 what the remainder is to tell us where we are on the wheel. So let me demonstrate that. So I equals the square root of -1. I times I equals the square root of -1 times the square root of -1, or the square root of -1 squared. And we know when we square square roots, the square root goes away, and we're just left with what's under the square root. I times I times I is the same as I times I squared. I squared is -1 times I, which is -1 times the square root of -1, or the negative of square root of 1. And then I to the 4th is I times I times I times I, which is I to the 4th, which equals -1, because I times I is I squared. The second I times I is I squared times -1, which is +1. And I forgot to say that any number except 0 to the 0 power is +1. So I to the 0 and I to the 4th have the same number. Okay, now what happens when we get higher than I to the 4th? So let's take something like I to the 9th power. What we do is we take 9 and divide it by 4, and we know that 9 divided by 4 is 2 with 1 remainder. So what that means, if I to the 0 is here, I to the 0, we go I to the first power, I squared, I cubed, I to the 4th and I to the 0 is the same thing. So if we go around twice around, so I make one circle completely around, I go around again, my one remainder lands me right there. So I to the 9th equals I to the 1, which is the square root of -1. I to the 9th equals I. And that's how you work the circle. So whatever the exponent is on I, divided by 4, and then you're going to have to draw this little diagram, and you have to know that I to the 0 is 1, I squared is -1, and I is I, and I cubed is -I. And then you just go around the circle. So if you have a remainder of 1, it's I. If you have a remainder of 2, it's I squared. If you have a remainder of 3, it's -I. If you have no remainder, it's the same as 1, using the circle method. Okay, the letter for the complex number system is not Z, but C. So this is a cross out. C. C stands for the complex number. You get a real number plus an imaginary part. So let me show you on a new slide. So like 3 plus 2i, or 0 plus I. Remember, 0 is a number, or -1 minus I, or any combination. These are called complex numbers. Now we can deal with complex number system.